Hi there. So excited about this. Today is a big day for us. And I believe that's true not just for HDB, the company, but for the entire database community. New database products don't launch often, but new categories of databases basically launch hardly ever. For example, relational databases were introduced in the 70s and were revolutionary. But the next big shakeup of the industry didn't happen until around 2010, when NoSQL movement was started. We believe that HDB defines a new category of databases, something that has an opportunity to forever change the way we think about data and how we work with data. So buckle up and prepare to spend some time with us today to be the first to witness the dawn of post-SQL era. Although, before we begin, I would like to thank you all for joining us here today. Some of you must be new to HDB, and I hope you'll love what we're about to show you. Special thanks go to those who have been following us for a long time, submitting GitHub issues, pull requests, proposing new features, beta testing pre-releases, and most importantly, encouraging us to continue pushing forward. We really want HDB to be community-driven. Together, we can finally make a developer-first database a reality. But before we start talking specifically about HDB, and why it is so special, let's reflect on the history of relational databases a little bit. Picture programming in the 70s. Okay, it's not so easy to do so actually, right? Not all of us were living, let alone programming those days. Spending some time on Wikipedia helps to imagine what it was like. Computers were basically things of science fiction. It was a few years before the advent of personal computers. Big businesses needed mainframes, which were essentially room-sized cabinets and required certified operators to help them to keep them running. Punch cards were very much a thing. It was about this time when relational databases and SQL were invented. And to be clear, the severe limitations of compute and storage actually had a positive impact on the relational databases design in general. The relational model avoids data duplication. It's flexible enough to represent almost anything. Most importantly, the model doesn't have any requirements around how data should be stored at the physical level, which, for example, open doors to the modern columnar databases and many other things. By all means, relational databases were extremely cleverly designed for the time, and this is the reason why they dominate the database market today. What database designers truly didn't have access to 50 years ago are modern programming languages and software architectures. Relational databases require us to think in tables, but that's just not how we think when we are writing JavaScript or Python code. SQL was designed to essentially allow businessmen implement reports in an English-like language. There was simply no requirement to make SQL composable or to make it play well with any programming languages. The solution to the I don't like tables problem is using an object relational mapper library, ORM for short. Invented roughly 30 years ago, these days using a norm is almost mandatory. Many use existing libraries, few can afford to build custom data layers, but the fact is that most don't want to interact with the relational databases directly at all. They're always enveloped with layers upon layers of abstraction and various services. This would all be okay if only ORMs were great. Unfortunately, they're not. Because ORMs typically support different databases, they sacrifice performance for compatibility. Their APIs are usually non-composable and very complex. They require you to essentially write SQL by hand even in slightly non-trivial cases. Most of the amazing engineering that goes into relational databases is not accessible with ORMs. If you use one, you likely use 10% of what your database is truly capable of. And this is where we finally want to say enough is enough and introduce you to HDB. Our goal with HDB is to eliminate all extra layers of abstraction. The database must feel like an integral part of your stack. You should have zero mental overhead when you work with your schema, when you're writing queries or do database maintenance. No ORMs are necessary We just want to forget about their existence. This is a classic example of easier said than done though. In order for us to do this, we had to rethink basically the entire database stack from top to bottom. So we started with the most fundamental layer naturally, the relational model itself. We enhanced it to basically turn your data into a graph while retaining most of the relational fundamentals. We call this new relational model extension a graph-relational model. And naturally, HDB is the first graph-relational database. While working on this new model, we are also designing a new query language. We call it HQL. And HQL looks like a child of SQL and GraphQL, and that's sort of intentional. Like with GraphQL, you can select nested data, access your graph. Like with SQL, you can perform computation. HQL has functional roots, so it's extremely composable. Working with it feels like writing code with a high-level programming language. It's a perfect target to build data APIs with. We spent years designing HQL, and the end result is a powerful, easy to learn, and just a beautiful language to use. So far, so good, you might say. What else? To which we can answer, hey, this is just a tip of the iceberg. First, it's an open secret in the industry that relational databases are just not ready for cloud or serverless. This is a big topic that deserves a proper talk or blog post on its own, but let me just say how we made sure that HDB will be ready for serverless. HDB can handle several orders of magnitude more concurrent connections than your typical SQL database. Our client libraries can automatically recover from network errors and replay failed transactions for you. We engineered our communication layer to minimize the number of round trips between the database and the client. Often you just need one network packet to send a complex data operation and just one to receive the result. Second, with HDB, we are not just building a new database for you. We are essentially redesigning from scratch the entire front end of the database. Just let me cherry pick a few cool things. For example, we spend a great deal of time making sure that our client APIs are simple, idiomatic, and fast for all languages that we support. That's currently Python, TypeScript, Go, Dino, and soon Rust. Our command line tools and the interactive shell are just best in class. You have to experience them to see for yourself, but trust me, we are obsessed with making them feel amazing. And while HQL is a much more powerful and expressive language than GraphQL, by now you probably get the theme, and you know that we are not fans of hiding the database behind layers and layers of extra services, so HDB supports GraphQL simply out of the box. And when it comes to evolving your schema, changing it, we have you covered with first-class migrations. This is perhaps one of the biggest pain points with relational databases that HDB makes a thing of the past. So there you have it. HDB 1.0 is here. It is fully open source. It's ready for you. But we don't want to stop at making it open source. We want to make our new graph relational model and our query language HQL an open standard. Our journey is no longer about just building a new database. We want to start a movement. We want to finally change the status quo. We want to finally have a database that we, software engineers, truly deserve. We have a great lineup of talks for you today. My co-founder Elvis is about to tell you more about the graph relational model and demonstrate what it can do for us. We'll have live demos, talks that give an overview of our schema, compilers, and the server architecture. Stick to the end to hear me once again talking about the short and long-term future of HDB. Thank you so much. Back to you, Colin.